Hello, good afternoon, everybody. Good afternoon, good morning, good evening. My name is Christopher Akpogome. You are welcome to the Chem Lab Chemistry Mastery Academy. Today, we are going to be looking at a very critical topic titled Kinetic Theory of Matter. Kinetic Theory of Matter. Now, we already understand that matter is anything that has mass and can occupy space. Matter is anything that has mass and can occupy what? Space. Now, kinetic theory of matter is basically trying to describe the behavior of what matter. Is trying to explain to us or trying to make us understand why matter behaves the way it behaves. Now, kinetic theory, as the name implies, the last time we made mention of scientific what method, where we have the first thing is observation, we have hypothesis, we have experiment, we have theory, isn't that so? And then we have law, right? Good. Now, theory is something that has room for modification. So it means that theory can change. It's only law that does not have any room for modification. Law is law, it cannot be changed. But theory can be modified. So kinetic theory of matter, like we have said, are those rules or those principles that help us to understand why matter behaves the way it behaves. Now, matter exists in three states. We have the solid, we have the liquid, and we have the gas. Now, why did we share them into different states? We share them into different states because they behave differently. They behave differently. But despite the fact that they behave differently, the kinetic theory of matter has made us to understand the reason why they behave differently and has also made us to know the common or similarities between each of them or amongst what each of them. Now, solid. We said solid has what? Fixed shape and volume. Solid has what? Fixed shape and volume. Now, the particles of solid vibrate in a fixed position. The particles of solid vibrate in a fixed what? Position. So, it therefore means that despite the fact that it is solid, the particles also what? Move. Okay? Despite the fact that it is what? Is solid, the particles also what? Move. Then we have high density and compressible. High density and what? Compressible. Now, solid, high density. When we say high density, we are talking about the weights. We are talking about what? The weights. High density and not compressible. What do you mean by not compressible? When you pick up a solid, you cannot compress the solid. You cannot compress the solid. Why can't you compress the solid? Because ordinarily, if you look at this diagram that we have here, the particles are already what? Joined to each other. Yes. So there is no space between the particles that make up a solid. Now, if there were to be spaces between the particles that make up the solid, it could have been possible to compress it. Because in the course of compressing it, what happens? The particles now cover up or occupy those spaces that what exist between them. But in this solid, there are no spaces that exist between them. The particles are jam-packed to each other. So compressing it is not what possible. Then we have liquid. Liquid, we say, has what? Fixed volume and variable shape. Fixed volume and variable shape. Fixed volume and variable shape. What does that mean? It means that when we take 1 liter of water, the volume of that water, which is liquid now, is what? 1 liter, right? When you take that 1 liter and pour it into what? 0.5 liter, which is half. What happens to it? Because the volume is already fixed, all of that liquid will not contain that 0.5, you will have some still remaining. Are you watching? Are you getting it now? So its volume is what? Fixed. Then another thing is it has variable shape. It has variable shape. That is, the shape can change. The shape can change. That is, it can take the shape of the what? Container. For example, now if you take a cup of water, eh, and then you take that cup of water and pour it into a what? A bucket. The shape that it had when it was in the cup is not the same shape it will assume when you pour it into a bucket that has a different shape from the cup. Are we following now? So the shape changes. That means it takes the shape of the what? Container. Then another thing about liquid is that the particles slide past each other. The particles slide past what? Each other. So in liquid, unlike solid, in liquid, there are spaces between the what? Particles. So because there are spaces between the particles, when the particles begin to move, they will slide over each other. Slide over each other, move over to this side, move over to this side, move over to this side. That's why you see that one of the things about your liquid is that your liquid can what? Flow. So the reason why it's able to flow is the reason why it's able to spread when you pour it is because the particles are allowed some level of movement over what? One another. Then we have liquid have moderate density. That is, the liquid is not as heavy as the what? The solid. So the solid is heavier than the what? The liquid. All right, then we have what? The gas. The gas has variable shape and what? Volume. Variable shape and what? Volume. That is, the state of gas will take the shape of the container. So it does not have a particular shape. The shape can change. The volume can also change. It does not have a particular what? Volume. It can change. So if, for instance, now you take what do you call it now? 1 kg gas. The volume is 1 kg, right? Good. Now remember, volume is the space occupied by the object, is it not so? Now, okay, let's say you have 3 kg cylinder and it's filled with gas, right? Now, 3 kg cylinder has 3 kg gas. So the volume of that gas is 3 kg, right? Now, we said the gas does not have a particular volume, that the volume changes. How? When you take that 3 kg cylinder, you open it in a room that is way bigger than the 3 kg. What happens? The gas goes and fill everywhere, fill all the spaces in that room. Now, remember, when it was in the container, it was 3 kg. When you open the cylinder, it filled the whole room, such that any corner in that room that you move to, you will actually perceive the smell of the gas. So you see that the gas has succeeded in what? Taking the shape of that space of that room where you released it into. That's why we said gas has what? Variable shape. It has variable what? Volume. Then another thing about gas is that the particles move freely and fast. So in gas, the rate at which the particles move is more freely and faster than what we have in liquid, than what we have in what? In solid. And so we say the name of the motion that the gaseous particles undergo is called Brownian motion. Brownian motion. That is haphazard or zigzag movement. So basically it doesn't have any direction. It just goes anyhow. Pew, 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 pew. Okay? Then another thing about gas is that it has low density. It's very light. It's not heavy. Okay? So gas or gaseous particles have the lightest weight among the 3 states of what? Matter. Then it can be compressed. It can be compressed. For example, now you want to go and fill your gas. Okay? You are taking 3 kg. Now, when they want to fill the gas, they are filling the gas from a big The gas is coming from a big tank, moving into what? That small cylinder. So you see that you can actually compress it. Okay? You can actually what? Compress it into what? That small cylinder. Alright. Now, all these different properties, those different characteristics that we have discussed concerning three states of matter, we wouldn't have been able to understand them if not for the kinetic theory of matter. So the question now is, what is responsible for the movement of these particles, which invariably affects the behavior of the different states of matter? Take note of what I just said. What is responsible for the movement of the particles of these different states of matter, which invariably what affects the behavior of these different states of matter? What is responsible? What is responsible for the movement of these particles? That is where kinetic theory of matter now comes in. Now, in kinetic theory of matter, we have about five postulates. Five postulates. Or we could say five explanations. Or we could call it five hypotheses. Or we could call it five principles. Now, what are they? The first one is gas molecules are in constant, rapid, random, straight line motion. They are in what? Gas molecules are in constant, rapid, random, straight line motion. What do we mean? What we are saying is this. I have explained that before when we talk about gas. That the molecules of the gas, that is the particles that make up your gas, they are always moving. And they move in different direction. That's what I mean by random. They move in different what? Direction, following a straight path. Okay, so you might have particles moving like this, straight. You might have particles moving like this, straight. You might have particles moving like this, straight. Are we following now? That's one of the postulates of kinetic theory of matter. Gas molecules are always in constant, random, straight line motion. Number two, we have collisions between molecules are perfectly elastic. Collisions between molecules are perfectly elastic. What are we saying? It's here on the screen. Collisions between molecules are perfectly what? Elastic. What are we saying? What we are saying is this. Remember, these particles are moving, okay? And in the course of moving, they collide with each other. They hit each other. And when they hit each other, the energy with which they use to hit each other, that is the energy with which they also separate from one another and move to different direction. So in the course of this collision, they don't lose any form of what? Energy. That's why we said the collision are what? Perfectly elastic. Remember, elastic is that when you stretch it, it can return back to its what? Original state before you stretched it. Are we following? So collisions are what? Perfectly what? Elastic. Therefore, no energy is what? Lost. Then another thing about the postulate of the kinetic theory of gases is that the total volume of gas molecules is negligible compared to the word container. That is, for gases, we don't consider the total volume as it relates to the container where you have the gas. Are we following now? What are we saying? The one that is much more important is what? The gas, not the container. The gas might be little as compared to what you have in the what? In the container. That's why we said the total volume of gas molecules is negligible compared to the what? Container. Then next we have forces of attraction between molecules are negligible. Forces of attraction between molecules are negligible. What are we saying? There is no force dragging the molecules to each other. That's what we are saying. There is no force dragging the particles of each of these states of matter to each other. There's no force. That's why you see that in solid, despite the fact that they are jam-packed together, they are moving in that fixed position to show you that there's no force what holding them together. Okay, that's why we say forces of attraction are what negligible. And lastly, we have average kinetic energy of molecules is proportional to what temperature. What does that mean? It means that the reason why these particles are moving is because of the what temperature of the environment where you find them. So if the temperature is high, then the energy with which the particles will move will also be high. If the temperature is low, the energy with which the particles will move will also be what? Low. That means temperature is a key factor in the different state of matter. That means temperature has a way of making solid change to liquid. Yes. For example, take a plastic container, which is a solid now, and you increase the temperature by applying heat. What happens? The solid will melt, right? And change into a liquid form. Is it not so? That solid plastic will melt, right? And change into a liquid form. What actually happened was that when the temperature increased beyond the normal of that solid, it caused the what? Particles that make up that solid to begin to move away from their current position, thereby creating spaces between each of those particles, and then it now assumes what? A liquid state. And in a liquid state, we say that there are spaces between the particles, that the particles are not joined together as we have in the what? In the solid. Now, what made the particles to separate and create that space is because of the temperature that is applied to that what? Solid. Same thing applies to the liquid. When you apply temperature or you increase the temperature of the environment where you have that liquid, what happens? The spaces, remember, there were spaces before, but now the spaces even become much more wider, that the particles now move at random, constantly, rapidly in straight line what? Position, now bringing liquid or changing liquid to what? To gas. So when you boil water, and then you now have water vapor coming out from the water. What happened was that when you apply heat to the water, you successfully increase the temperature of that liquid. And when the temperature of that liquid increased, it also increased the average kinetic energy of the particles. And so the particles began to what? Move faster than they were moving before. All right. Thank you very much. I'll see you in our next class. Do well to subscribe to our channel so that you can get the latest update as it concerns our class. Thank you very much. Have a nice day.